Welcome, students. This is Calculus 2. We're covering section 6.2, and first up is the area between two curves. And we're going to look at this in two respects. We're going to look at this with respect to x and then with respect to y. If I notice they've given me two functions, what you're going to be doing is you'll plug those into your calculator and then you'll need to look at them. You need to decide which one's on top and which one is on the bottom. And it will be the top function minus the bottom function. And we're going to look at it with respect to x first. And that means our limits of integration must be with respect to x as well. And we'll need to figure out what those limits of integration are. Let's figure out what this region is first. So it's going to be below this 1 plus x squared, and that could be anything all in here, but it wants the region defined by below this f and above this g, and it also says the y-axis, so it's going to be this region defined right here. So you'll need to know these intersection points. Now you can get those with the calculator, you can set the two functions equal, whatever, but you're going to have to get those intersection points. And then you're actually going to have to decide whether or not you want this. Now the first ones are fairly straightforward, but you're going to have to decide whether or not you want this differentiated with respect to x or y. So we need to discuss how that happens. What I typically like to do is I will draw a little rectangle here. Let me fix that. So first up, deciding whether or not you're going to differentiate with respect to x and y is kind of the first step. And these first ones, we're going to tell you, do this with respect to x, do this with respect to y. So let's look at why I might do this with respect to x. Notice the top of this rectangle and the bottom of this rectangle. The top always is on the f, the bottom is always on the y, and I can slide this rectangle, which is what you physically do in your mind, slide this rectangle all along through here, and you'll see that the top is always on the f and the bottom is always on the g. If I had made the rectangle, say, the other direction, like, let's do it on this one. If I had made it as such, then notice how in some cases that the top function would be the f, and on the other regard it would be on the g. So I would have to break this. If I was going to integrate this with respect to y, I would have to break it up in two separate sections, and you'll see that as we go on. Also note that my rectangle, because my limits of integration are going to be along this x-axis, so my limits of integration go from 0 to 1. So I would write this as area equals from 0 to 1, the top function, which is 1 over 1 plus x squared, minus the bottom function, which is the g, which is x minus 1/2. And then I'm going to integrate this with respect to x, and I'll do my integration and get back with you. When I integrate this, I get inverse tangent and just the straight little polynomial. I'm going to plug in a 1, and then I'll plug in a 0 and do just like we did in Calc 1. I'll end up with the inverse tangent of 1, and that'll be minus 1/2 plus 1/2, and then minus plugging in that 0 everywhere, and when I plug in that 0 I will then get 0, and this ends up being pi over 4, and that would be the area of the region in between those two curves and the y-axis. Now we'll go on to example 2. Okay, it's all well and good when they draw this little picture and they have that in the book, but you won't always be given the picture. A lot of times you'll have to do it on your calculator, and then you'll have to figure out which function is on top, which one's on bottom. You'll have to physically get these intersection points so that you'll be able to get your limits of integration. And now let's look at drawing our little rectangle, which I do every single time I do one of these problems. I always draw this rectangle, and I'm going to decide what function is on top, which one is on bottom of my little rectangle, and I make sure as I physically slide this little rectangle back and forth in the in between these two curves, I try to make sure that I always have the same function on top and on bottom. Otherwise I have to break it up into separate sections. This one I'll have to break up into separate sections anyway, because on the left hand side I basically have the function this side. Between here and here I have negative 2x because I have the absolute value of 2x, and then from this 0 to this 3 I'm looking at positive 2x. So I'm going to break this up into two separate integrals. So my area is going to be limits of integration. My x ranges from -1 to 0. -1 to 0. The function that's always on top in that region is this x plus 3 minus the one that's always on the bottom, and that one would be this minus 2x because that's the function that presents in that particular region. Doing this with respect to x, and then I also want, because that would give me this area right in through here, next I want this area this way, so my limits of integration are going to be from 0 to that x value is 3. The function that's always on top is x plus 3 minus the function that's always on the bottom, and that's just a plain old 2x with respect to x, and then I'm going to integrate that thing and get my answer for you. Alright, here's just a little bit of algebra manipulation in this second step. I just combined with that 2x, or that negative 2x, then I integrated, and now I'm going to plug in my limits of integration. Alright, after plugging in and doing my arithmetic, I get as my area a 6, and next we're going to look at the area bounded between the region of two curves with respect to y. So we're going to do this with respect to y, and I'm going to graph on my calculator these two functions, and then we're going to look at our rectangle in between. Alright, note that in my calculator I graphed this. All of these tick marks are in a scale of 1, so you can just count them as we go through, which is what I'm going to do. So I want the region bounded by these two curves and the x-axis. So basically I'm looking at this region here, and if I were to create my little rectangle like we talked about before, I want you to notice that if I draw my rectangle straight down here, if I scoot it along, move it left and right and integrate with respect to x, you see how I would have this function x plus 6 on the top here, the x-axis here. If I go along this path, when I got to this point, I would be on the function the x plus 6 and then the x cubed. So I'm not going to do it that way this time. What I'm going to do is integrate with respect to y, which means I'm going to do it with my rectangle this way. And as I slide it up and down, notice if I slide it up and down, the function that is always on top is this x cubed, and the function that is always on bottom is this x plus 6. Now, note that I've got to get this in terms of y, so I'm going to rewrite these functions using algebra, so I'm going to do that now. Alright, and this point is the point 2, 8, and this point is obviously, let's see, 1, 2, 3, 4, 5, 6, 7, -7, 0. I'm just going to concern myself with these y values because my area is going to be my limits of integration. It goes from y is 0 here because of the x-axis on up to 8 because I'm integrating with respect to y. The function that is considered to be on top is the rightmost one, and that is the y to the 1/3 minus this y minus 6 dy. Now note that I could have also found the area using the x-axis. I could have done this with respect to x, but I would have had to have broken it into a couple of different integrals. I'm going to do this calculus 1 bit here. I'm going to integrate that and then get the computation, the arithmetic. Alright, and once I integrate and then plug in that 8 and then that 0, you'll find that your answer is 28, and that would be the area enclosed in this region. We'll go to the next one. They're wanting me to find the area in the region that's in the first quadrant, and that would be this. Note that if I try to integrate with respect to x, I've got an issue because I have the red one on top here and then the x-axis, and when I get to here I have both the red and the blue. I'd have to break that up, and it might be, it'd be a bit tricky. Let's see what it would look like if I integrate with respect to y and can just make it one nice integral, which it would, because all the way up and down this I would get it just along that y. So this rectangle, as you move it up and down, has as its rightmost always my limits of integration. The one that's always on the right would be this linear guy right here. I have to rewrite that in terms of y, so that would just be a y plus 4 minus the one that is on my leftmost side, that is this guy here. So I would have to rewrite that in terms y, and doing that is just y to the 3/2 dy. I'm going to compute this integration and get my area. Computing that integration and then plugging those values in, I get 56/5 as my area. And that concludes section 6.2. If you have any questions regarding this, I hope to see you at the Collaborate or send me an email. Don't get too bogged down in any one homework problem. Please send me an email and I will work through the solution of that problem with you. And have a great day.